in the DevOps and Cloud series that DSC is going to have. Yes, first we'll be having more workshops as time goes on. So I'm glad a lot of you have joined. Like, so this will be a this will be a beneficial workshop for all of you. So basically, the works the workshop I is an introductory one. I am not going to show you how to do anything as such, but I'll be showing them what, because DevOps is a field that is like a supplementary field. It is not a major thing like data science or full stack development or Android development, but it is something that complements all of them. So this workshop will be focusing on how DevOps works with all of us, how what all is there to see in DevOps and what is there to learn in DevOps. So this workshop is basically introductory, like I said before, on this. Uh, so there are, as you can see in the contents page, in the agenda, there are some gray categories and then some green categories. So all categories are theoretical. I'll be going to theory, discussing case studies, but in the green ones, I've got demos prepared where I can show you how this works in a real world scenario. As far as questions go, uh, after every slide, I'll have a pause where you can ask your questions. Please feel free to ask a lot of questions because a lot of this is might seem a little high level, especially for the second years here. So do not shy away. At the end of the workshop, I will be giving you all a document. I prepared a document where I have referred all the sources from where I learned DevOps and where you all could start learning. Okay, this is a tool that I can use. This is somewhere that I can refer to. So I prepared a document for that, which I'll be giving in the end of the workshop. So everybody on board, let's get started. So the first slide is pretty much why did this year we focus on this subject? Why are we focusing on DevOps and cloud so much? Well, as mentioned before, it is something that complements all technical fields, be it cybersecurity, IoT, Android, but every field is, it requires DevOps. It can be optimized by DevOps. So it is a growing trend. Like a lot of companies are looking for DevOps interns, they're looking for DevOps engineers, or they prefer full stack engineers with DevOps skills, because it's not necessary that if you know DevOps, you don't need to do full stack. So there's a huge rise. Like I myself, even when I was working as a data scientist, because I knew DevOps, they asked me to work DevOps as well, because there's a huge demand in industry, especially amongst a lot of startups, and there are not many people with this skill set. So as a career wise, it's a very useful skill to have. But personally as well, when you get used to DevOps, right, your projects, your work, your very awareness about different technologies increases a lot. So that is the second reason why you should at least look into DevOps on a on the topmost layer. Don't go in deep, but just understand how your interest, how your field of interest can be influenced by this skill set. Okay, now everyone must be having the question of what exactly DevOps is. So DevOps has a lot of definitions. On this slide, I have definitions from Medium article, I have definitions from Wikipedia, I have definition from the AWS blog, and some random definitions you hear around. So the reason why there are so many definitions is because, like I said, DevOps is not a main field; it's a supplementary field. So everyone has a different approach to DevOps. Everyone has a different set of DevOps skills or philosophies that they promote in their own development mode. So thus it's a very vague term as such. So I'm going to give my own interpretation of it. So basically DevOps includes first is philosophies, how you logically approach the problem. Like anytime you're making a project, basically what we do when we make a project is हम पहले सोचते हैं कि ठीक है, this is our input, we have to get to this output. So let's start programming, and then we start programming, we make a single main file that runs everything, and then we're like, okay, wait, I need to put this on a server, तो उसके लिए मैं एक express code डाल देता हूँ, I need to put it here, I'll add this, and as we go ahead, as the requirements increase, we build on it. DevOps is the other way around. DevOps is first you think, first you plan, what is the exact way you want to go about it. And this is very much inspired by Agile. So second years, you will not know what agile is right now. It comes in your third year, and when you learn agile, you will hate agile, because not because agile is bad, but because that's how poorly they teach you the concept. So agile is basically a set of principles how you approach a problem. We won't be focusing too much on that, because right now I'll be teaching you DevOps more towards as a developer side. Second, include practices. Now, this is something which I'll be focusing it on a lot more than tools and technologies, because if you understand what DevOps is trying to achieve, what these practices are trying to achieve in your development, that will help you a lot more than knowing the tools, because then you can make your own tools if you want, make your own scripts if you want. And lastly, DevOps includes tools, because in the end, the reason this field has blown up and exploded like this is because there are tools and technologies that have made DevOps very easy and very obtainable for everyone. Any questions till now? You can switch on your mic and just ask away. Any suggestions that should I slow down, or should I go a little more in deep with these slides, or can I move on? मेरा mic on है ना?
Yes, sir. I think no one has any questions, so we can move, I guess.
Yeah. Okay. So next up is what DevOps offers. First thing it offers is scalability and optimization. So I think the best example I can take is the SPPU. Like, I'm pretty sure अभी आने वाला है वो exam form भरने वाला, and I know all of us here have done that 2 day waiting कि bro अब server चल रहा है, form print हो रहा है, form निकल रहा है. If SPPU develops a more DevOps approach, then their servers would not slow down that easily, and we wouldn't have to wait hours or days to get our exam forms. एक बार में हो जाता काम. Second is where DevOps offers is smoother collaborations. Have you ever worked on a project कि तुम्हें काम किया, you keep adding to the project, you keep adding to the project, but as you evolve the project आगे, the base, the things you made initially start breaking. So with DevOps, that does not happen. Your whatever project you make using DevOps scales infinitely. So you can keep upgrading it, release all versions, 9 version, all this, but whenever you add a new feature, right, the old features don't break, and vice versa. Security, DevOps is all about security. It is very important to it, and that is why most cybersecurity, if you're looking into cybersecurity as a career path, DevOps is a must for you. Like, it's not an option, it's a must for you. And last, reliability, which is related to scalability and optimization. And I won't go see right now. I can understand right now the slides I had are very vague, but then that is how vague the entire definition is as such. But then we can't ignore it. So just bear with me. Things will get interesting. A bit vague, I know, but still, any doubts, any queries? I'll just assume no and move forward. So this is where we're going to start into what all is involved in DevOps, which won't be as vague as what is DevOps. So there are a lot of components in this, which we'll be going in detail. I'll have demonstrations. I would request people, if you do not have a notebook pen, to keep noting down, because there are a lot of terms, a lot of terminology that I'll use, and it would be really better for you if you note down the terms. So even if you either you can ask me those terms later, or you can Google them yourselves. So I'm going to tackle the most boring component of DevOps first, but extremely important, which is resource management. So considering there's a good number of third years here, or second years, even those who have done a lot of projects, you generally approach कि तुम्हें जो आता है उसमें तुम project बनाते हो. Like, if you're someone who's working C++, you would prefer working in C++. Now, this is awareness. If you know multiple languages, like right by the time you're in fourth year, you know C++, you know JavaScript, you know Python. That is there by the time you get fourth year. But then when you get there, how do you decide what you make a project in? So a first part of DevOps is the awareness कि what all APIs are there, cloud में क्या क्या बना सकता हूँ मैं, what all resources can I use, what all techniques can I use, what all third party APIs can I use. Like, for example, maps. Maps के case में you have got Google Maps, you've got here, and you've got OpenStreetMaps. Now all three of them are useful, but it depends on what you require. Google Maps is extremely powerful, but it's extremely expensive as well for many of its functions. Here is also useful, but it is a little outdated. OpenStreetMaps is very useful and up to date, but it doesn't have those powerful features like maps and roads and all these things. And OpenStreetMaps is free. So having an idea of which is the most important technology which will impact a project the most is very important. Second is the architectural design. A lot of people here when making projects, they go one, like I said, you go one by one. ये डालना तो ये पीछे डाल दिया, नया route बना दिया. In DevOps, you give time. You take time at the starting of project development, and you think, yes, this is how I should go about it, so I can scale it later on. In the future plans, does it? So you think about the future. DevOps keeps the future in mind. What is the next? So accordingly, you decide your architecture. I will be focusing on what I mean by architecture soon. So bear with me. And the last and most important resource management is getting maximum, performance at minimal cost. Whenever you work as cloud or DevOps, the first thing a company will ask you is to help them reduce their costs. So having an understanding of which is the most cost-effective way to get things done is easy. So you just have to go through prices and all these things. Like even right now, Indians will know that it is a inbuilt thing. If there's something free, we'll use that rather than using something that's not free. So that's also part of DevOps, knowing what is the most cost-effective method. Any doubts till now, or can I move to architecture? Brilliant. Next up is architectures. So this is like a more complex thing to talk about. So there are two basic types of architecture. Like on your local machine, when you run an application, it's a single machine on which you're running all your applications. So that is what you call a monolithic application, where all your programs are running on a single server. Like if you're talking about a web app, it's running on a single server. So this is very good when you're starting off your project or when your project is very small. But as your project gets bigger, right, of the problem of scalability comes. At some point, the program will be too much for your computer to handle. कि RAM खत्म हो गया, ROM खत्म हो गया, computer slow हो गया, those problems come up. So that is, while monolithic designs are much easier, they are less efficient. And the second problem with monolithic is scaling them up. When you're talking about servers, what people do sometimes is if you have a computer hosting a website and also बहुत सारे requests आते हैं, you replicate them, you scale them up. So in this, what happens is, let's say a server has two apps, app 1 and app 2. App 1 is getting 0 requests, but app 2 पे एक के बाद एक request, it's just overloading it. So I scale up, but when I scale up, I have to not only scale up app 1, but I have to scale app 2, but scale up app 1 as well. So in the end, the cost of my server is doubled. क्योंकि मुझे अभी दो server लगाने पड़ रहे to run two apps because all of it was built in a single structure. Microservice, on the other hand, is dividing your task. Like every application you make runs on a different smaller PC. So when it comes to scaling up, you only scale up those applications which require to be scaled up, and those which do not can be scaled down. So this is more optimal when it comes to handling performance and handling cost as well. And right now, most companies work with microservice architecture because of its dynamic structure. These are not absolute कि या तो microservice होगा या तो monolithic ही होगा. You can always have programs or software designs which are both in nature. कि software wise मैंने microservice design किया है, but मैंने उस सबको deploy बस एक machine पे किया है. So that's monolithic. So that also that it all depends on what you're trying to make. In the end, DevOps, like I said, is just a supplement. Oh, so again, I'm going to give you a case study on the number of ways how you can approach an architecture. But before I go to the case study, any doubt in microservice and monolithic? Because this is very important with what's coming. So abhi aage aane wala hai, it will be based on this. This is something that you need to understand before we go ahead. So any doubts, please don't feel shy, because I don't think you're supposed to know this. आज तक किसी ने पढ़ाया नहीं होगा. So ask away any doubts you have.
In monolithic, so
Yes.
why there's a problem between those two apps? Like we are attaching two more apps in a single server, right? There, like we are using two servers in the scaling part of for monolithic.
Yeah.
So in that we are adding two servers to each app, so one server, two servers to like one server to two apps.
No, see, so the app works on the server. The app needs the server to run. Like any program requires computer to run. The server is the hardware for it. So in the first case, now apps are overloading server. मैंने imagine तूने computer पे एक program game चलाया कुछ चलाया which is taking too much RAM off and your computer is slowing down. You cannot have that with your server. So what you do is जो भी तेरा पूरा setup है ना software hardware का, you replicate it to scale it up. So now you've got two of those things, so your load is distributed. So that is what's happening here. So to reduce the load, I'm just replicating it. So now instead of one machine handling all my problems, I've got two machines splitting the load.
Okay. Okay, so it will like reduce the effort. So it's like, won't it be more effective? Like, right? It will be more effective. Now it will. We can
scale,
utilize more.
If it scales up, it will be more powerful. That is there.
Okay. So like, so in the microservices, like we also did this almost the same thing, right? Like there was to each we were assigning one servers.
But it's the thing is, in monolithic, you will need a more powerful server. If you have, let's say, laptop basis only, if you have a Pentium laptop, like a Pentium core laptop with a very small RAM, and you have to run basically this powerful server is like an i7 core with 16 GB RAM, but these smaller ones are like Pentium cores with 4 GB RAM. So when I have to scale up the monolithic structure, I have to buy. I'm buying two i7 machines with 16 GB RAM, which is not required, because in the others, because I just need to increase app 2. App 1 को नहीं चाहिए दूसरा machine. App 2 को चाहिए दूसरी machine. But because of app 2, app 1 is also being split, and my entire cost is getting doubled. Did you get that part? But in microservices, my cost is not being doubled. Only the cost of running app 2 is getting doubled. App 1 doesn't need anything, so it's not being bothered at all. So the cost, the total cost is just increasing to 50%.
Okay, yeah, right. Okay. Yes. Okay, sir.
Anyone else? Yes, because this is a very important topic, and if you don't understand this beyond this, it'll get really, really heavy. Okay, all right. Anyway, if later on you want me to touch the topic again, I will touch it. I have no problem in that. But please be sure that you know this, because if this workshop has to help you, you need to understand this. So an example of a web application running. So all of you, I'm assuming जितने यहाँ आए हैं उनने कभी HTML file तो बनाई है. So when you made your first HTML app, how did you run it? You just opened it on your browser. You just put the location and open it on the browser, and HTML render हो गया उधर, and you also ये HTML चल गया है. So that is what you call static hosting. You're just making an HTML file and you're just submitting it and running it. So the same HTML file will come for everyone. It's not a static page. Any doubts in static hosting? Because I'll be going one by one here. I think static hosting is very simple. Next up, when we come to a server, that we need to make not a static app, but we need to make a a program that accepts requests, and based on the request sends you variable data depending on what the request asks for, like what we make using Node.js and Express. So for those kind of things, we use what we call a single server on which we run Node.js and we connect to it. Like Facebook has, okay, that's initially any social media application you make will be run on a server. So there'll be a program running there. I send a request to the server, and the server sends data back, and that data can be HTML, it can be JSON, it can be anything. So that kind of hosting is called hosting on a single server. Okay. Third part is hosting on a cluster. Now this is where things get complicated. Remember I explained you microservices architecture. This is how a microservice architecture works. You've got you've got your small parts. So a lot of applications, like, okay, an example of microservice is like, let's say you've got a database, इसमें तुम्हें insert, delete, read करना है. So one server will handle the read request. One server will handle the insert request. One server will handle read request. And depending, obviously read request will be more than delete or insert. So उसके according read को ज़्यादा power दूंगा मैं and बाकी दोनों कम दूंगा. So microservice are hosted on a cluster of PCs that are interconnected with each other. Any doubt there?
Sir, can you explain again that cluster one?
All right. So I'm assuming everyone here has worked with a database of any kind. So let's say I'm going to compare server and cluster, so I can explain you better. So database you have to make three functions of interacting with the database. That is read, insert, and delete. Now on a single server, this single computer will be handling all three. You send a request na, I want to read this data, this server will be like, ठीक है, I'll send you data. If you say I want to insert data, यही server बोलेगा, ठीक है, I'll manage it, मैं तुझे तेरा data insert कर रहा हूँ. तो delete करना है, वो एक ही server सबको संभाल रहा है. It is handling all your requests. जितने भी requests आ रहे हैं, जितने type के requests आ रहे हैं, वो सब वो एक ही चीज handle कर रहा है. In a cluster, I have put different machines. एक machine मेरा read कर रहा है, एक machine मेरा insert कर रहा है, और एक machine मेरा delete कर रहा है. But all three of them are interconnected with the same database. So that way the load is distributed. In microservice, the word you have to go is distributed. You hear distributed computing or all these things. This is where it comes from. That whatever you want to get done, you split over multiple machines. Did that clear your doubt?
Yes, sir.
Okay. Thank you.
Sir?
Yeah?
Sir, how these machines know about each other? That you said one machine gets a get request, other post request. Then how do they communicate with each other?
They're all interconnected. Like in the cluster, it's not like they're separate machines. I have connection between them. Each machine is informed कि यहाँ get हुआ है, वहाँ पे read, delete to insert हुआ है. So that is part. It's not. That is why microservices is a little hard to set up. When you're setting up microservices, right, it's not an easy task because you have to make sure they're interconnected. Because if they're not interconnected, like you said, पता है वहाँ से insert हुआ, पता चला यहाँ से get तो हो रहा है. So for that, you need to make sure you've got good. That's where all your DSC and all these concepts come into play. You have to design that logic that all these machines are in touch with each other. Like how you and your friends are in touch with each other. These machines are like just three people doing three different tasks. Like in a bank, एक बंदा तेरा, he's processing your check. One guy is making a new account, and one guy is giving you credit card or debit card. All three of them work for the exact same organization. All three of them work interconnect to each other. But the guy who's handling the bank, applications will not be uska workload is different than the guy handling checks. So it's something like that. It's a system of computers working together. And in a single server, if it is a single server system in a bank, the same guy is handling banking applications, credit card, debit, सब कुछ एक ही बंदा संभाल रहा है. So that is how it's different. Did I clear it? Yeah. So last is serverless hosting, which basically means you do not set up a server. Serverless hosting is a cloud feature. I will not go deep into it. I just tell on the surface कि मतलब कि तुम server बनाओ ही मत, तुम बस code submit करो, वो चल रहा है cloud पे. So serverless hosting and serverless computing, I will go in deep later on when we have a workshop on cloud. Because right now I feel if I go to explain serverless hosting, बाकी सब गुल हो जाएगा, तो मैं उस पर नहीं जा रहा हूँ. Any doubt in the first three? cluster and monolithic microservice clusters?
No, sir.
So,
Yes.
so can we categorize the hosting on a cluster similar to cloud hosting, or is it anything?
Everything is cloud hosting. All four options.
Okay, okay, okay. So got it.
Yeah. So everything. Whenever I'm talking about something, the only thing I will mention what you do on your local machine is static hosting and hosting on single server. But what you do on cloud is the exact same. But with cloud, you get more options. You can do a cluster hosting, you can interconnect computers. So everything I say is applicable to cloud. If there's something that's only applicable to local machines, I will mention it clearly.
Okay.
So here, okay, these are three types of architecture I've presented. So as I've explained the architecture as well, I've also put these money bags. So static hosting is very cheap, but there's not much you can do with static hosting. And similarly, as the applications get more powerful on the cloud, the cost increases. So when you're deciding resource management, we have to decide where do I stop? Do I need a cluster? या single server पे चल जाएगा मेरा? Because as you go ahead, performance-wise, cost increases, and you need to balance them. Yeah.
So my doubt is that how we cost static hosting to us as I host in on my personal IP only.
All right. When you open a static hosting page, like when you open on your computer, right, ऊपर एक address आता है. There's an address that comes, /documents /webd/index.html.
Yes,
Similarly,
sir.
so you all know about the existence of Google Drive and storage files and all these things.
Yes,
So
sir.
on the internet, there are a lot of storage drives. I'll be coming to them later as well, but there are a lot of storage drives. So each storage location on the drive has an address. Like on your PC, every memory has an address, right? On the internet, every computer, every storage, everything has an address. So instead of connecting, so generally what you do is you connect to the IP of the server with whom you want to communicate to. But in static hosting, you don't. Static hosting to directly वहाँ से HTML file उठा रहा है and render कर रहा है. Like how you do on a computer, to next HTML file उठा रहा है. So that's how static hosting is different from what you do on a local machine.
Okay, sir.
Okay. Any other doubts? Okay, I will say no, but I'm glad a lot of you asked your doubts. All of you are clear on your doubts because things just get better here from here on. So this is the very core of DevOps, because anyone who will ever go into DevOps will always look into CICD. I don't care if you are a full stack web developer, you're an Android developer, you work in C++, you work in Android, you work as a data scientist. CICD is a software development lifecycle process, so everyone is bothered by it. So simply explaining, CICD is continuous integration, continuous deployment. So it's divided into two parts: continuous integration and continuous deployment. I'm going to focus on each of them, and I'm going to take a break. First, I'll explain CI, and then I'll take a break, and then I'll come to CD. And obviously, in the future slides, I'll be looking into them more deeply. But it's important that you follow through with this. CI is basically, let's say you have an application, hello, you have any kind of hello world application. You put this on a server, and everyone can see hello world. Now you want to change it to hello India. That's a new upgrade to your previously existing code. So you've thought about it, you've planned it, and you've changed the code. But now you have to make sure that everything is working fine. Like if you're working with Node.js, you need to make sure your dependencies are there, which you will require, like language dependencies or library dependencies. Like those who work with Python, you have to add your MongoDB dependency using that, or all these things, right? So you have to add your dependencies as well. And at the same time, imagine you change hello India to hello world to hello India, and hello disappears accidentally by a logical error in code. So you need to make sure there's something there to test whatever you're making does not break the previous code and it's meeting the requirements that you require. So CI is all about that, continuous integration. It makes sure that as your code grows, it is aware of its dependencies and it's not breaking. That whenever I make some code, whenever I push into my, if I push into my repository, Git repository, जो मेरा वो code बन रहा है, it is not a broken code, it's a properly working code that anyone else can get it clone and it will work with them as well. So that is where CI comes into play. Any doubts in CI? All right, even if you don't have doubts now, I'll be explaining CI. I have a demonstration for this one. So we'll go much detail into this. So if you have some confusion all, just keep it, don't worry, I'm coming to them. CD is basically now CI के बाद you made your code, you put your dependencies and you got a package. अब तुझे ये package server पे डालना है, but server पे already पुराना वाला चल रहा है. Your hello world is running there. You've made your hello India वाला code and you wanted to overwrite कि कैसे भी ये code instead of पुराना code वहाँ से replace होके नया code website चल जाए on your website, right? Like if you want to change your website, you want this old change to go to your new stage. On your local machine, you'll overwrite files. वो चल जाएगा. But when you go on cloud, तुझे अपनी laptop से वो files वहाँ भेजनी है and वो वहाँ पे replace होके should run smoothly. That is where continuous deployment comes into picture. And these two together are a stage of how when you update your code, तेरा final product भी change हो रहा है. Any doubts in CD? What deployment is? I mean, I'll go into detail how they work. Right now, I need you to be sure of that you understand what is the purpose of it. What is continuous integration achieving? What is continuous deployment achieving? So as long as you're clear with that, we can move on to the next slides. All right, let's start with CI then. So first in CI is build. Now, I have put a lot of examples in languages. Like I said before, building is basically packaging an application with its dependencies, you know, with all it require, or if it's a compilable language, you compile the code. Like for Java, building, for C++, building is compiling. When you compile and you get an executable file, that is your compilation. That is you building your code. And for example, if you want to build your C++ with extra, you know, I'm pretty sure second years अभी तक तुम लोगों का वो start हो चुका है, computer graphics. So you use you use OpenGL for that. So when you compile with OpenGL, you have to add some dependencies as well. So building is that. Building is making sure your program, whatever source code you have written, is becoming an executable with all its dependencies. So in Python, generally there is a scripting language, so you don't have any kind of build. But when you're making a pip package, like how you download pandas, and when you're making something like that, you build. That time you get a build feature of building the wheels and distributable packages, which I won't go in detail, but yes, there is build for that as well. JavaScript developers here, those who work with frameworks like React, because I know a lot of you part of OSS must have done that. So React build is there, Angular Clay NG build is there. You've got packages, you've got all these packages you need to install. You've got node modules. So build is basically downloading all your node modules that it would require and then making a build file for it. That is JavaScript and build. And Android developers, for you guys, building is basically converting your code into APKs. That is it. So that is how building works. Because in the end, if you want to deploy your application, you need to make it runnable. So building does that. Building makes your application runnable. Any doubts building? Anyone, maybe any language related doubt कि इस language build कैसे होता है या how do everyone has done build before. Build is not something that is an option. अब Java code run करना है, compile करना पड़ेगा. So that is what build is. So any doubt in build again, because I won't be touching build again in the detail में. All right. Next up is I have testing. So testing is something nobody here does. If you are here for DevOps workshop, I'm pretty sure एक दो ने आज तक कभी test लिखा होगा. So testing, like I said before, it is to ensure that when you make a new feature, your old program does not break. So testing is used by a lot of big companies to make sure that whatever they release is not a buggy release. So there are testing frameworks. I personally have worked majorly with Python and JavaScript. So in Python, there are two testing libraries that I worked with, PyTest and DocTest. And in JavaScript, there's Mocha, Chai, and Jest, which are all very good testing frameworks. But here, what I want to focus on is what testing achieves. I have a demonstration of testing as well. What testing achieves is it ensures कि जो तुमने code बनाया है, it works. कि अभी तो you made a code पहले on which is working, but when you make version 2, you unnoticed to you somehow broken version 1. कि version 1 में feature है, version 2 में नहीं आ रहा. But then if you have a testing mode, it will not let you deploy it. It will tell you कि तुमने जो code बनाया है, it has broken your previous code. कि right now as a unit, your code is not working. So testing is extremely useful in debugging, and it is a practice like in companies, industrial experience speaking here, you have got, I know, 3 or 4 layers of testing, from computer automated tests to people testing your software. So testing is very important, and any doubts in testing? All right, no doubts in testing. Deployment. Now deployment is getting your code into your server. Now like server is just like another computer. Just imagine you've got 2 laptops, एक पे जब तू काम करते हो and दूसरा is located in the cloud. That is what a server is basically. So ideally what people do is when you start off with that, you go to your server wala computer through your own laptop, you connect to it and you control it, and then you download your Node.js something like, or C++ library, download them, and then you git clone your code, those code to code repository, you git clone it there, and then you start running it, which is how amateurs do it. In a real industrial scale, you cannot do that every time you release a version. So what we do is we set up deployment. So in deployment, what it manages deployment on a whole. There are test server. This is a test link. Is test link to a guy who's developing tests. Ki, haan, everything working fine. Then you've got your prod wala server. This it goes to the client. The client checks that, and you've got how to make sure the dependencies are there. The environment is there to build the product. So deployment handles all of that. Here, like go through slide if you want to, but you will not understand deployment as much as once I show you when I run the code. I'll be running I made a pipeline and I'm going to show it to you how CICD works. Any doubts in abhi tak? Test your deployment?
Sir, can I make my machine a deployable machine? Like I can deploy a server on my own machine?
You can, but there are a lot of settings you'll have to change for that, because obviously abhi cloud aaya hai. Pehle cloud nahi tha. Pehle people used to buy servers, connect them to the internet. So to make your own machine deployable, first you will have to expose your ports. Port 80 for port 80 and port 443 or any other port that you're using. So it's a lot of operating system related programming that you'll have to do. But yes, even your laptop can become WoW. But then again, there are some network rules as well, internet rules that you have to keep in mind, because your laptop connects to the internet in a very different way than what cloud servers do. So you can obviously make your laptop a server for the cloud, and even AWS, Google Cloud has features of letting you use your own machine as a server. We call them on-premise instances. So you can definitely do that, like very much, but there's a lot of janjat, and the fact that you have to keep your laptop on all the time. So generally it's not preferred. But good question.
Okay, sir.
Anyone else? Like,
hello. Yeah, hi,
yeah.
Arun. Sorry. Yeah, I'm a little bit confused between cloud and server. Like, are they different thing, or do I need to have a cloud to make it a server there?
So basically, cloud, regardless of how it sounds, is actually not what it sounds like. Basically, what cloud is, it is a huge farm of machines. Like in India, it's located in Mumbai, and I think they're building one in Kolkata as well right now. I'm not sure about that, but so what cloud is, it's a huge farm of machines. like you've got powerful machines, weaker machines, and these machines are just like your normal laptop, and they are connected to the internet in every way possible. So those machines are what we call servers. Like, you see your data is in cloud. Even right now, you think this meeting is happening on the cloud. No, this meeting is being processed on some machine owned by Microsoft in the server farm. Around the world, there are at least 20-25 server farms which are connected together to form what we call the cloud. There's nothing in the sky. Everything's on the ground. And all these server farms, like if you connect to your server, when you connect to your server, you have to use collab. And when you go to collab, just type ping. The net speed you get at server is probably the best net speed in the entire world, because the server is literally in the internet. So a server is basically a machine located in the server farm, and that server farm is what we generally call cloud. So cloud is an entire set of servers and servers and storage and whatnot. Basically, cloud is the internet, and server is a machine located there that you have rented to use.
Okay, got it. Thanks.
Yeah, so your laptop can be a server, no doubt about that, because server is just a computer located in the cloud. Because it's serving some files, we call it a server. Whereas it is just another computer. Literally, उसमें Ubuntu Windows होता है. You open it, you can go to Windows, and फिर बाहर जाके you can start your own program again. There is no complicated shit behind the server. It is just another computer located in the cloud. So no need to worry about that. Obviously, later on in workshop, if we have a workshop on cloud particularly, I will teach you how to set up your own servers on cloud, how to utilize them, but that is for later. So this is a very light part of it. It is not involved in CICD much, but companies like Google, Airbnb focus a lot on it. That is linting. So I'm pretty sure all of you have used these, like Sublime Text or VS Code for programming. Linting is basically, linting is ideally the technical definition. Linting is very different, but in DevOps, linting refers to that as I'm coding, right, my text editor tells me this code is wrong. So I can make styles. Do you know there are naming conventions? Like, I don't mean like what letters you can use, but in JavaScript you use camel case for variable naming. But in C++ for global variables you use all caps. So these are what you call variable styles. How you style your code. Some people don't use curly brackets with for loops or with if else, and some people prefer using that. So linting is to make sure everyone uses the same style of programming. So everyone is programming in the same style and they can understand each other's code. The variable naming. Most people will name their code int A, int B, int C. So you want to prevent that. So linting prevents that. Linting, the minute you write int A, int B, int C, linting will ask you to change the variable names. So linting is enabled in your VS Code and you can customize it. For those of you who want to look into it, you can customize your VS Code to help you with linting. I have never used linting in Python, but in JavaScript, you can use lint using ESLint. It is a really tough tool to configure, but when you're working in large projects, it's an extremely useful tool. And the second part of DevOps is documentation. I think everyone's heard of it. The documents, guys, it's very simple. Documentation pada karo, documentation banaya karo. It is good for everyone. So any doubts in linting? I'm not taking any doubts for documentation as such, but any doubts in linting?
Sir, how is it playing role in DevOps side? Like linting, we generally use to make our code clean, or we can say a good practice. Like how this is affecting it.
Even documentation is for good practice. DevOps, like I said, is not only about tools; it's about philosophies. Now, CICD is basically that your project should never stop growing. That is the main purpose of CICD. If you don't lint your code, and tomorrow if a new person joins your organization, if your code is well linted, it will be much easier for that person, for someone else who's working with you to understand this is what this person wanted to do with this code. Good practices are what DevOps is all about. DevOps mein jitne bhi you've heard good practices, this is a good practice, this convention. DevOps is you follow those conventions. Those conventions are now your rules. So that is why linting is very important. It is not automate. Obviously tools में practice नहीं आता linting, but as a practice documentation and linting is essential to good DevOps. Like as a DevOps, whenever I work with DevOps intern, this is something that I've obviously focused on, that if I am doing DevOps for you, you better lint your code, you better document your code, because it helps a lot. So that is why it is an important part of DevOps and why I've included this in the slide.
Excuse me, sir. So it can change from company to company, right?
Yes, every company has a different linting style. If you go to ESLint, there are some demos. I can, like, if you go to GitHub, wait. So every company different linting styles. So I can just show you Airbnb. So they have these ESLint rule files. So this is a Airbnb's JavaScript guides. So here you can see the entire rules of what they require as a, if you're a React developer, what are their rules, like the naming rules or style rules. So you can find all the companies, like big companies, Google, Airbnb ke rules, linting rules online. Like it is that important that they have these things online. You need to know how we code. And this is an important part when you join these companies as well. They focus that you should know what linting is about.
Yes, thank you, sir.
Any other doubt? All right, moving on. So here we come where all things come together and I can explain you beautifully. Okay, we will go step by step here. If you have a notebook, get your pen up, because this is where everything starts making sense. So I have my code in master. I have put my code, I put my build files, configuration files, everything, and I have a documentation in my master branch on GitHub. That's what everyone does. I know that most of you don't make a second branch to do your changes, but start doing that. It's a DevOps practice that you make all your changes on a new branch. You only commit the final changes to master. So here again, to encourage that amongst you, I have made a branch and I made some changes in those branch, and then I try to merge it with the original. So here it's a lot of Git terms, GitHub terms, and if you haven't used GitHub or Git abhi tak, I strongly recommend you start, because I think it's pretty late for you. It's second year ho gaya, abhi GitHub Git nahi pata to. So when I do this, have you noticed in a lot of GitHub pages you have it? I think I still have it open, right? So do you all know what this is? You see a lot of these tags, a lot of places when you work, right? When you work online, you see a lot of these tags. So basically, these tags are whenever someone does a pull request, a merge request, right? We have got automated bots. These automated bots check whether the changes made in this new code are not are valid.
Sir, your voice is not audible.
Yes, it might be a net issue. He'll rejoin it.
Sorry, we are just calling, sir. Like there might be some internet issue. Please wait for a few minutes.
So sorry, guys. Like the worst part of it. Can you hear me now?
Yes, sir.
Yes,
Yes.
sir, you
Yes,
are
you're audible.
audible. Screen
Yeah.
is not visible, sir.
Oh wait, I not start screen sharing. Is the screen visible now?
Yes,
Yes,
sir.
sir, it is.
Perfect.
Okay. Where did I get disconnected exactly? Or should I start from the start again?
I'm branching, sir. Initially
Okay.
only. Yeah.
Yeah. So yeah. So when you are working, you basically let's say you have to make a change in your code. So you make a branch, you make those changes in the branch, and once you make the change in the branch, we have got bots, or we got CI bots. So these CI bots, we according to the rules given in the master branch, check whether the at this second branch is working, is the build passing, is this code actually, is it's a good code, it's working or not. So that's what the first check comes. So if the merge is possible and the build passes, then only will we merge the code. Once we merge the code, then there's a change in master. So this pipeline is detecting changes in master. So now there's a change in master. Whatever code you have, it gets sent to your CI. So this green part is your CI. So before I step into CI, any doubts कि इस stage में क्या हुआ?
Sir, who sets the rules?
I'll show you configuration files. So you make the rules, you make the build configuration as well test configuration. So generally build configuration basically is you just start the code and check कि ये code चल रहा है या नहीं. So I have a demonstration of that. So I'll show you what build is there, if the build is passing or
Is
not.
it some kind of testing cases we write in the config?
No, we do not write. We do not write tested cases in the config. We write test in the code itself. In the config, I am writing that this is a node project. This should have this dependencies, and these dependencies should compile. Basically, this is not a logical part. This is the compilation part. It does this code compile or not? In building, when we check build, we are checking if the code is building is compiling. So we are checking if this code is compiling or not.
And sir, like the bots which are determining the changes, are they provided by GitHub or we just
Yes,
have to
GitHub can
make our...
provide them. On GitHub, people have made bots so that you can set up your own CI bots for Git. I'll show you. I'll be demonstrating GitHub Actions as well, how GitHub Actions works and for all these things. So those of you must have heard, GitHub has something called GitHub Actions, which allows you to perform all these tasks. Any other doubts within this section?
Sir, the final merging is done by the user now?
No, GitHub. Git does the merge.
No, the approving the pull request like that.
Yeah, that part has to be done by the user.
Okay, sir.
Yeah. So
like the bot is only checking whether it is right or wrong, but it's only depend on the user who have to check whether it's like what is being solved or not. Is it like this?
see, in a pull request, nobody has the time to check codes because will you go through the entire code कि कितना change किया है इसने? Pull request में the person just mentions कि this is what I've done. You like for example, let's say I'm making an application in which I want a map. So The pull request will be a feature of adding the map. So it will return pull request added map and also and the build pass. And when I as the owner of master open that pull request, right, मुझे वहां पे bot ने बता दिया है कि this merge is possible and this build is passing. जो उसने code में changes किए हैं, it is not breaking the compilation as well. The code is getting compiled. So now I know as a person कि this code works and the merge is also possible. So then I can consider कि हाँ, I can merge this. Got it?
Okay, sir. Yeah.
So all right. So next up, now this is the part where the human interaction ends. After this, it is all automated. Your job as a developer was make the code, submit the code. Your work is over here. From this point on, it is all automated, which is the beauty of DevOps. So first we go to CI. So I'll be showing you CIs. Basically, so CI is basically a second environment, a second computer, which is not owned by you, but owned by, maybe the service provider like Google or GitHub. So, but in CI, you can check your code. So what we do in a CI is basically CI may your code gets git cloned. Simple as that. Your code comes, it gets copied as it is. Then CI will check dependencies. It will install all your dependencies, and then it will test it. Is this code working with the test? Now, when I say tested, I'm talking about the in-code tests. When we talk about testing code, like build will also be checked. Obviously, when the build compiles, then only can a code be submitted. But when I talk about testing, this is where testing works most. Unit by unit, all the tests that are written in the code, right? They are all working. So it will install dependencies, run that code, test it, and then it will build it. Meaning it will download the dependencies, compile it, make it like a proper package with everything inside it, like a zip package. एक zip file में सारे dependencies सब कुछ डाल दिया है. So it's basically like Amazon went to your house, Amazon went to your shop, it took what you wanted, उसके साथ देखा कि हाँ इसके साथ added ये भी डालना पड़ेगा. It checked is this product in good condition, and then they packaged it, put a ribbon on top of it. That is what is happening in the CI. Any doubts in CI? Am I disconnected?
I know, so you're online.
No, you're
All right. So CI में कोई doubt नहीं है. All right.
don't think so. किसी को और नहीं है.
Okay, I think I'll continue then. किसी का आया नहीं. So CI has generated a zip file or any kind of hashable or compressed file in which your dependencies, your source code, everything is there. And this is what will go to your server wala computer where it will run. So that is where your CD comes. Now what your CD does is that it takes the build files from the CI and it runs it on the test server. The test server is a computer जिसकी IP is not public but only accessible to a select few people generally. So it's generally used to see how the final product looks on a screen to the client, and that is tested by your quality assurance guy. There's a guy hired, generally he's your manager or your testing guy, who checks the assurance. After that is done, so he will get an email कि a new version of the program has been uploaded to test server. Please check and reply. And when he replies, the bot sees if this is a positive reply, I will deploy this to the main production server. If it's not, then I'll notify the developer team. So let's just say सब चल गया है, सब बढ़िया है, quality assurance guy loves it. This goes to the production server. Now in the production server, imagine you're using Flipkart and suddenly तूने click की link पे Flipkart बंद हो गया. Why? Because Flipkart is updating itself. That does not happen because what they do is, like, remember when I talked about replicating. So initially, let's say these blue servers are the old version and the gray ones here are the new ones. So in the first step, it will replicate the original server and split loads. So now you've got two machines running version 1 and दोनों को 50-50 load मिल रहा है. Then you will update one of them to version 2 and slowly and now you've got जितने तुम्हारे request आ रहे हैं, half of them are going to the old site and half of them are coming to the new site or the new app. And then over time you start increasing कि more requests should go to the new server. And after a certain point of time, all your requests are going to the new server and you delete the old one. So that is how deployment works smoothly with zero downtime. Okay, any doubts on CD and in general, CD?
Sir,
can you
CD not
repeat
understood.
after QA, please?
What?
Sir, not
Sir,
clear with CD.
Was my voice breaking a lot?
A few, sir. I think it's my problem or it's for others. I don't know. But your voice is breaking.
All right, I'll just go through CD again.
अमन दोबारा बोल दे क्वेश्चन.
I understood what he said. So CD basically, I have got, let's say I've got two computers, two servers on the cloud. One is accessible only to me. One is accessible to everyone in the whole world for using my application. I send my code first to the test server. As CI को package मिल गया, एक zip file मिल गया code के साथ. उसको बस unzip करना है, run करना है, उतना ही करना है बस. So it will first unzip it and run it in the test server. When it does that, the QA guy checks is this good or not. If he likes it, he approves, and then we go to production. So in the production servers, obviously you can't remove code and then run a new code because it'll cause downtime. बीच में code बंद हो जाएगा. Imagine you're watching Netflix and बीच में your show just ends because sorry we're updating Netflix. That does not happen because what they do is they take their server and first they create a replica of it and they split the load. There's a 50-50 load in each machine. Then they upgrade one of them to version 2. So you've got two machines, replica to each other, but one is version 1, one is version 2. And your load is split, 50 here, 50 here. Then over time, that load increases. You have 40, 30, 20, or you have 50, 60, 70, 80. And in the end, all your traffic, all the requests are coming to your new server. So you can shut down your old server, get deleted, and now you again come back to a single server. Understood?
Okay, sir. Means we are gradually shifting our traffic from one server to another server. First of all, creating a clone of it, and then we are doing that
Updating
transfer.
it and
Updating that
updating it.
new one. Okay, sir. Understand.
Yes. So I am going to show you now. The pipeline I am going to show you does not use this method as such. Like the CI part is same, but the CD is different. So, all right. So, all right. So this is an application I have built. Can everyone see the application?
Sir, can you increase the font size because it's too small?
All right. Preference is on. Where is the font size? मिल गया Oh, okay. This is better. So this is just a simple node server which is hosting this index.html, and I have already sanctioned the server online which is running this code. If any one of you want, you can test this IP because it's being hosted online on a server, and it's a very simple application which says hello Pune, the DevOps workshop, and I have added a route to it to show you that it can do more things. So here it just sends you a JSON object. So basically I have made this just to demonstrate what CICD can do. So this is my code, right? So In this code, I have my index.js, which is my server's code. I have a package.json, which is basically describing of what all dependencies I require, what all dependencies will be required by me. Then I have a build spec and an app spec. Now these files are what I wanted to focus on. The build spec file basically is my build key. How do I want to build this file? So इसमें simple है. First, I need a Node.js environment, and then I need to just run npm install, because this does not. This the only build it requires is installing dependencies, and then artifacts is my output. I want all my files in a zip to be submitted to this after CI stage. So this is my commands for CI. This is my command for CD. So in CD, I have told him that my server uses Linux. The whatever files that I get from my CI, I have to copy paste in this location, and then before installing, I have to run this script, and after I've installed and everything is set up, I have to run this script. So right now I'm going to go and let's just change this to hello world, and I'm going to call this new change. So right now I have pushed my code to my GitHub repo. So you can see 30 seconds ago, Alan John new change. So right now my code has been updated. So this is what I'm using for my CI/CD. This is an AWS powered tool. You can use any other tool. I have used this tool just so that I can show you how it's working. So in this pipeline, first is my source stage. I don't know why this pipeline takes so long. So first is my source stage. So this stage is basically triggered when I get code from my repo. Like this stage basically is कि मेरे repo GitHub informing code pipeline that my code has just been changed. So it downloads that code from there. Any doubts with this stage? Okay, everyone's clear with source then? Then whatever code I
Sir, you have
download from my
deployed this
GitHub.
on AWS.
Yes.
Okay.
Yeah, and it's being hosted on the internet right now. This is not on my local machine. This is on the internet. You can check this app. I think I can send it to you guys, right? If chat is enabled. No, I can't. Chatting is not enabled. But if it was, I would have sent you the IP address. So you can check it. It is online. It is on the, like, people can actually see this. So first source came. When the code changed here in my GitHub, when the code changed, noticed yes, the code has changed. It downloaded the code and it triggered the pipeline. Let's start CI/CD. Next is CI, the build stage. So obviously it shows that it succeeded because I was explaining the whole. It's automatically. I don't have to do anything right now. So yeah. So like I said, yeah, in here I had defined what all do I want in a build stage. So only two things are defined. I want Node.js there, and my build command is npm install. I want to download the dependencies. And yeah, here also the first it has just installed Node.js first. It has installed Node.js, and then it just ran my command. My command being npm install. Everything worked out. Everything had no errors. So in the end, all my files were found, packaged, and then sent to deployment. Any doubts here? How this build is working? like where is this code running or how is this code running or what is built, या नहीं आ रहा समझ में anything.
सर AWS ही नहीं समझ में आ रहा तो
AWS
मतलब
कुछ नहीं है यार. Don't get intimidated by AWS. Like don't get intimidated by it. Is literally nothing. It is just like it is like your computer lab. Like college में हमारा computer lab होता है ना. It is just that you've got different machines there that work. Basically, what I'm trying to show you here is this is a CI. In this part, right, the CI part, this is a CI. This is what a CI looks like. I'm just trying to give you a demonstration of what a CI looks like, how it works. So in my CI, I have just here mentioned that my CI, this is common for all CIs. I just want Node.js there and I want npm install there. And similarly here, I have got Node.js and npm install and khatam, succeeded, over.
Sir, I want to ask that the command which we have written over there, that npm build command, that is run over the server or means I don't understand. It's run over your package inside your computer or in the server,
it is run on a third server owned by AWS. Like this server has nothing to do with me. I am just asking the server to build my code. Now there are three things you have to understand. There is my laptop. There is the server on which I'm hosting my website. And then there is AWS ka khud ka server, that AWS owns that server. AWS is offering me this CI service. So AWS के server पे पहले a request goes कि this person requires a server. Well, I don't need this always. I just need it temporarily to build my packages, right? So first a request goes submitted. Then it is queued कि okay, someone is waiting to get a slot to build his own code. Then I download. Then all these steps happen where the build takes place one by one. Got it?
Okay. Means sir that the build task is automatically done by that command which we have written over in that code.
Yes, build is automatically done by this. This is everything. All the automatic stuff is done by because this thing knows that whatever code comes, regardless of what changes I make, it will always require Node.js and it will require me to do npm install. And that is all my CI. All I've done is I have rented like a small temporary computer for like a short amount of time. उसमें मैंने कोड डाला अपना, डिपेंडेंसीज डाली, पूरे को बिल्ड किया, पुट लगा पैकेज बना दिया, उसकी जिप फाइल बना दिया एंड आई सेंड इट टू माय सर्वर.
एलन, अच्छा क्या हर बार npm इंस्टॉल होगा क्या? मैं जितनी बार भी पुश करूंगा?
बिकॉज़ सी तू जितनी बार पुश करेगा, जब कोड सर्वर पे जाएगा उसको npm आई चाहिए होगा ना, तो npm हर बार चलेगा.
अच्छा, तो isn't it like जैसे हम अपने मशीन पे करते हैं तो सिर्फ जो एक्स्ट्रा जो नई कॉन्फ़िग फाइल्स आती है वो नहीं को करता है ना, तो उससे बार-बार
बिकॉज़ सी जब तू GitHub पे कोड डालता है तो GitHub पे तो नोड मॉड्यूल्स नहीं डाले हैं. और GitHub पे यू डू नॉट पुट योर नोड मॉड्यूल.
कॉन्फ़िग फाइल है
कौन सी पैकेज जेसन? व्हाट?
हाँ, पैकेज जेसन है ना.
हाँ तो पैकेज जेसन देखते हैं npm करता है वो.
ठीक है, तो यही जानना था कि वो मतलब ये हर बार एक ओवरहेड ही है ना कि जो बार-बार npm इंस्टॉल करना ही है.
तो ये ओवरहेड कैसे? इट्स नॉट ऑन योर हेड और देयर हेड ना. दिस इज इट हैज टू बी डन व्हेन यू आर बिल्डिंग योर कोड.
एक बहुत ही वैसा क्वेश्चन हो सकता है, तूने बताया भी हो, बट ऐसे इन जनरल इन केस अगर ये CI वाला पार्ट ना होता तो मैं भी जब GitHub पे डालता तो वहां पे स्टेप क्या होता?
You have not implemented CI yet, right?
मैंने अभी कोई ऐसा कॉन्फ़िग या कुछ नहीं किया है, तो बट अगर
तू सर्वर पे कैसे कोड डालता है फिर? If you're hosting it anywhere, if you have ever done that, I'm pretty sure you have. How would you do that?
इट्स सिंपल कि मैंने ऑफ कोर्स वहां पे तो जैसे मैंने फॉर एग्जांपल हेरोकू पे कर लेते हैं, तो हेरोकू पे अगर मेरे को पुश करना हुआ तो फॉर एग्जांपल उनकी CLI से होता है, तो वो डायरेक्ट ही वहीं पे मैं पुश कर देता हूँ, वो उनका होस्ट हो जाता है. हाँ, तो यहाँ पे मेरे को ऐसा CI वाला पार्ट नहीं जरूरत हुई.
तो देख Heroku पे there are limitations. You cannot run every kind of application there. Right now मैं तो Node का एग्जांपल दिया है. Tomorrow someone will give you a more complicated application, something a very complex architecture. तो उसमें you will require dependency building, you will require jar building, you will require all these steps. So that is where CI comes into place. अब यहाँ पे I have not put any testing. यहाँ पे if I wanted, if I had right now HTML फाइल में टेस्टिंग क्या करूँगा? I could also put npm test. So इस CI स्टेज में मेरी टेस्टिंग भी हो रहा है, ये तेरा Heroku पे नहीं होगा because you directly deploying them. Heroku पे भी npmi हो रहा है in the end.
हाँ हाँ, वहाँ पे भी सेम ये प्रोसेस तो हो ही रहे हैं।
ये हो रहा है, वो you are not seeing this process. The same process is happening there as well. But here I am giving you the control over this process कि तू टेस्टिंग भी कर इसमें, तू इंस्टॉल भी कर, तू रिएक्ट का ऐप भी बिल्ड कर, तू whatever you want to कर इस स्टेज में. Prepare your application, like get it ready for the server.
ओके, अच्छा समझ गया। सो इट्स काइंड ऑफ वहाँ उस केस में क्या है कि जहाँ पे हम कुछ खुद से नहीं प्री डिफाइन कर रहे हैं, वहाँ पे जो सर्विस है उसने जिस तरीके से कर रखा है वैसे ही होगा। बट अगर मैं खुद के कुछ बीच में चाहता हूँ कुछ चीजें टेस्ट केसेस रन हो या कुछ कहीं और से बिल्ड होके आए, तो मैं फिर इसको पाइपलाइन में सेट करता जाऊंगा ना।
यस। सो उसके बाद लास्ट स्टेज इज डिप्लॉयमेंट. Deployment is nothing. जो तेरा zip file आया है, it will replace your code on the server with the code that you have submitted. It will unzip it there and submit it there. And because this was run a long time ago, अभी तक I think changes आ गए हैं. It is now Hello World, so Hello Pune, and it is on my server. And it has been changed. And everything was automatic. All I had to do was push my code in Git के master branch में. And that is CICD. Any questions?
So we can do this in GitHub pages now?
I have never used GitHub pages, but I don't think so, because GitHub pages are meant for mainly for documentation purposes generally. You do not put your big heavy duty applications there.
Okay sir.
सो सर आपने जो फर्स्ट कोड पुश किया था वो टेस्ट सर्वर पे पुश किया था या फिर अपने ओरिजिनल सर्वर पे?
नहीं, because एक HTML page ही है, like I said, I don't have a production server. This is a test server only. If you saw the link, it was a very puta easy to with a lot of, it's not a link that makes sense. So I don't have a production server because it will cost me money to set up production and all that. So मेरे पास बस test है. So our pipeline ends here.
Okay. Yes.
So everyone is clear on CICD?
एलन, ये इनिशिएट कब होता है? लाइक जब मैंने पुश कर दिया मास्टर ब्रांच में उसी टाइम ये CICD इनिशिएट हो जाएगा?
हाँ.
और अगर ओके, तो और जैसे कि मान ले जो मेरा कोड बेस है उसमें मैंने मेंशन नहीं किया है कि मान ले एक डिपेंडेंसी नीड है लेकिन मैंने वहाँ पे नहीं लिखा है कि ये मुझे चाहिए, तो बेसिकली ये बिल्ड में एरर देना चाहिए।
बिल्ड में एरर दे देगा, बिल्ड और टेस्ट में अगर तेरा लॉजिकली भी गलत है, टेस्ट में एरर, बिल्ड में एरर, एंड इट वोंट टेक इट एनीवेयर फॉरवर्ड. एरर आगे तो वही स्टॉप हो जाएगा पाइपलाइन.
अच्छा, तो मतलब मैंने गिटहब में पुश कर दिया तो कोड चेंज हुआ मेरे मास्टर ब्रांच में अगर एरर है तो?
तेरा मास्टर ब्रांच में चेंज हुआ होगा.
ओके, बट अच्छा, तो मास्टर ब्रांच में पुश करना इज डिफरेंट एंड वो जो मेरे जो मैंने AWS का सर्वर खरीदा या फिर जो भी मेरा वो है वहाँ पे वो बिल्ड फेल बता देगा मेरे को?
हाँ, बिल्ड या इट वोंट इवन गो टू AWS. वो बीच रास्ते में विल इन्फॉर्म यू. यू कैन कनेक्ट टू योर Slack and Slack में मैसेज आ जाएगा that someone pushed this code, it failed the build stage, and it give you the error log if you want.
Okay.
So it makes it smoother. तुझे बस कोड बनाना है, पुश करना है. अगर चला तो चल गया पूरा, नहीं चला तो पता चल गया क्या गलत क्या है. So it automates the entire thing for you.
Okay, तो हाँ समझा. लेकिन ये बिल्ड सब सारे टेक स्टैक का शायद अलग होता है ना, क्योंकि अगर एंड्रॉयड में मैं बिल्ड करता हूँ तो वो मतलब रन करने के पहले ही बिल्ड करता है और उसी टाइम पे मुझे एरर दे देता है कि डिपेंडेंसी का है.
लाइक आई सेड ना, यहाँ पे अगर लाइक आई सेड Heroku वाला एग्जांपल उसने लिया था, सो प्री डिफाइंड है. यहाँ पे एवरीथिंग बिल्ड्स अकॉर्डिंग टू व्हाट आई से इट शुड बिल्ड एज. मैं बताता हूँ कि तू हाउ विल यू, आई एम डिस्क्राइबिंग कि हाउ यू विल बिल्ड, हाउ यू विल टेस्ट.
ओके, गॉट इट.
एलन, कोई एग्जांपल में तू बता सकता है क्या कि जहाँ पे तुझे ऐसा CI की तूने कुछ अच्छा उस पे किया हो?
बहुत भाई. माय फर्स्ट इंटर्नशिप वाज अबाउट बिल्डिंग CICD पाइपलाइंस. माय फर्स्ट,
तो वहाँ पे कोई अच्छा यूज केस जहाँ पे
रिएक्ट ऐप और रिएक्ट एप्लीकेशन, एक रिएक्ट सर्वर जो चलाना है, So उसके लिए पहले you have to download the dependencies, testing, and then you have to build React build करना होता है. उसके बाद you have to start the server on the production wo. So उसमें CI/CD comes very handy because this is a production thing and there are actually clients using it. Right now, if any company is not using CI/CD, it's not a good company as such, because maybe on the surface of it you must not notice, but all like abhi, the reason it is such a big thing is because all companies are using it. This saves time, this saves code. So it is not a question about why you should use it. It should not, it's a question why not. If there is something, and as such, abhi to maine AWS use kiya. If you use something like Jenkins, it is completely free. It saves you time and it's zero cost. So why should you not use this? All right. So any other doubts regarding CI/CD? आगे बढ़ गया.
सर कैन आई से कि जो मेरी CICD है इट्स लाइक जो मैंने स्क्रिप्ट्स लिखी हैं वही एट द एंड रन करके ऑटोमेट कर रही हैं ये सारी चीज़ें.
Yes.
ओके सर.
All right. So that's up for CI/CD. This next section is even worse. So Docker. So I assure you, the reason DevOps today is so popular is because of Docker. Docker has completely revolutionized our understanding of how we deploy applications. So generally, what you do in a package is मैंने उस package में मैंने बस dependencies डाली और मैंने बस code डाला. In the end, अगर सर्वर पे Node.js installed नहीं है, मेरा कोड नहीं चलेगा. Agar if I'm running an SQL server, my SQL server, it requires not Microsoft SQL server, it requires Microsoft. So I cannot run it on Ubuntu server. तो वो बना के मैं कुछ कर नहीं सकता उसका मैं. So lot of these problems came into picture. Lot of these problems की Windows पे Ubuntu के app चलाने के लिए you have to download VM. All these things when came to picture, someone came up with the idea of Docker. What Docker does is it gives you like a virtual machine, but it is not. It virtualizes an entire machine for you. A section of your computer compartmentalizes it. So it gives you a package with the operating system, with a runtime, with the source code, and with dependencies. So it is like small runnable computers which only run one task, and it can run anywhere on any computer, any system on the world. It has zero requirements. The only requirement it has is Docker होना चाहिए. It is like it's like a single USB port for all your needs, something on the same grounds. So Docker is not only for DevOps guys but also for data scientists, developers, everyone. Like even right now, later on I'll be showing you Grafana, all these things. Almost every application on my laptop is running using Docker because it is much easier to manage them when I'm running using Docker. It might be slightly heavier, but it does save me time. So why and what is Docker? So I'm pretty sure there might be people amongst you who use VirtualBox. So Docker is nothing but it is like VirtualBox, but it is lighter. Like your VirtualBox basically puts your own run some other operating system on your computer infrastructure using something as an intermediate stage. So you got a lot of overhead of running that application just because वो Ubuntu का application था उससे Windows चलाना था. You have taken up a lot of overhead. Your operating system चाहिए, मुझे ये चाहिए, everything and all that, and that is very heavy. But with the help of Docker, it does not matter कि तेरा application को Node चाहिए, Python चाहिए, क्या चाहिए. Those dependencies don't matter. You just make your application, make them a Docker container, and run them wherever you want them to run. So that is what Docker basically is. So you have Docker images, which are like your Docker images are like your class or structure. When you're working in any kind of language, you make a class and then you call an object of the class. So a Docker image is basically the class itself, and a Docker container is an object of that class. So with the help of this, we can scale things very fast. So that is where Docker is, and lightweight as well. So if on my PC I want to run a program that uses Python 2, now these days nobody uses Python 2, but पुराना code है, काम का है, Python चलाना है, I don't need to download Python 2 again. I've got Docker, वो Docker चला देगा उसको. So that is the power of Docker. That's the first point I want to cover is what Docker does. Any doubts in this?
सर डॉकर अपने जो भी मशीन्स के स्पेसिफिकेशंस होते हैं वही यूज़ करते हैं, हमें इसको एक्सटर्नली कुछ स्पेसिफाई नहीं करना होता कि इतनी जीबी रैम इसको यूज़ करना है।
नो,
तो ये काम हम वर्चुअल मशीन में करते हैं, राइट?
हाँ, तो वर्चुअल मशीन का ओवरहेड भी ज्यादा होता है। सी इन दी एंड जो तेरा डॉकर योर मशीन डॉकर इज अनदर एप्लीकेशन, एनी डॉकर कंटेनर अनदर एप्लीकेशन फॉर इट। इफ इट डजंट हैव द रैम और रिसोर्स टू यूज इट, इट वोंट यूज इट। वो दैट इज फॉर डॉकर टू हाउ इट मैनेजेस योर एप्लीकेशंस। Virtual machine में it does not, your original system, right, cannot do anything about what's running in the virtual machine, and there's a lot of overhead. Like you can run 2 virtual machines on a computer at the same time at max on a normal laptop, but I have actually ran around 10-15 Docker containers वो भी सारे बड़े-बड़े at the same time.
ओके, लिसन।
सर एक वेबडी प्रोजेक्ट के लिए डॉकर कैसे यूज कर सकते हैं?
वो भी है, I actually have that as well. It's coming up. Docker can be used for any project. Literally, WebD, data science. Like I have interned as a full stack developer, as a DevOps intern, and as a data scientist, and I've used Docker in all 3 internships. And that it's actually given me an edge. I won't lie. It is something that's helped me a lot. Even within Docker,
Sir, I don't understand what the overhead means.
Overhead means
the term has been repeated 2 or 3 times, but I didn't understand.
Overhead means repetition. Like basically पहले उसने बोला था packages. When you're talking about downloading packages, अगर you're downloading a software, उसकी कोई dependencies है, तो फिर से सारी dependency download नहीं करेगा। तो बस जो missing है, when you've got a huge tray of food, you will not take another tray of food to complete your existing bowl. You will just take what you are missing. So overhead is basically already है मेरे पास, but because मुझे कुछ और चाहिए था, मैंने ये फिर से ले लिया। Understood?
Yes, sir.
हाँ, so it's like there's a combo कि I had a shirt, I wanted to buy a pant, but pant shirt combo में था, तो मैंने pant shirt दोनों ले लिए. Now that shirt is overhead. Now I had to buy 2 shirts just because I wanted a pant. So something like that. Moving on to how Docker is again more lighter is because while your virtual machine stores each thing separately, Docker stores everything in a tree structure. So a Docker image made of layers. एक तेरा operating system का layer होगा, एक तेरा Node या Python का runtime environment होगा, एक layer तेरा dependency packages होगा, और एक layer तेरा application code होगा. So right now these are 4 containers, 4 images, but some images use the same layers. So because ideally 4 images with 4 layers will make 16 layers, but because they use similar layers, Docker optimizes it and you only need to store 12 layers. So this is something, well, right now it might not seem much, but when you're running large architecture and large softwares, right, this makes a huge difference. Because it allows you to run, Python and Node.js applications together as if they were part of the same application. Any doubts on that?
तो सर डॉकर एक टेम्पररी एनवायरनमेंट क्रिएट करता है।
डॉकर एक टेम्पररी एनवायरनमेंट कैसे थे? इट्स लाइक अ टेम्पररी शेल। इट्स लाइक तेरा पूरा कंप्यूटर है एंड तेरा बीच में छोटे से डब्बे में डॉकर है। लाइक इट वर्क्स ऑन द सेम लाइन एज वर्चुअल मशीन, इट्स जस्ट लाइटर एंड इट इज डिप्लॉयबल, इट्स एग्जीक्यूटेबल। इट्स अ वर्चुअल मशीन दैट्स एग्जीक्यूटेबल। तुझे हर बार वर्चुअल मशीन घुस के सब सेटअप नहीं करना पड़ेगा। तुझे उस वर्चुअल मशीन को रन करना है, जो भी उसका एंड पॉइंट है, यू कैन रन दैट। It's like a small containerized computer with one endpoint, which is your function, जो तुझे चाहिए।
Okay, sir.
So, how Docker helps? Okay, so someone raised a question about how Docker helps web developers. So, for those of you, obviously these terms might seem very heavy कि क्या USWG and क्या बोल दिया। So, don't bother with that. That is not what I want to get your attention for. What my attention here is, this is a Docker image. ये Docker image का नाम है। This Docker image allows me to make a production-ready, load-balanced Flask application, which takes a lot of configuration to make. Okay, but with the help of this image, I can only make a main. I can make a main.py file and submit it to the Docker image and run it. And just like that, I will have an entire full production ready Flask application ready. And that is how Docker simplifies stuff. You don't have to make things again and again. You don't have to configure this. Like all for those guys who are doing machine learning projects and all these things, you don't need to set up a proper Flask app or just to deploy your models. एक सब main.py बनाना, उसमें function बनाना, attach it to this particular Docker image, and boom, just like that, you have a production ready server. You have a production ready, servable application ready. So Docker works on the principle of inheritance. So this image is based on this image, which is a production ready server, but without Flask, without Python, and that is based on this, which is basically Python के साथ. So इस सब image combine करके you have made a new image that is more useful to you. And all images at the base are operating system images. की Ubuntu का image, all these images. So an image is like a class structure, like it's like a class object. It's like a data type. So Ubuntu like that, Docker like that allows you to inherit and grow. You can make your own Docker images on the basis of the already made. What amazing Docker image tha, but you wanted something similar to that. So instead of making something from scratch, right? उनका Docker image लो, changes करो और अपना बना दो. So that is another reason why Docker is so very, very popular, because it reduces your workload a lot. Any doubts on this part?
No, sir.
So second is CICD. Where it comes CICD. With Docker, I do not need a CI/CD pipeline. Now I know you might say pura pad liya, but then if you know Docker, if you understand Docker, you do not need CI/CD. It is as simple as that. जब तुम Docker image build कर रहे हो, that time you will do CI, and तुम Docker image run कर रहे हो, वो तुम्हारा CD हो गया. That is it. And because it can run anywhere, you don't have to worry about setting up dependencies. Server पे Docker होगा, Docker image server पे डाल दो, वो वहाँ चल जाएगा, तुम्हारा your server is ready. No setup required, nothing required. Your CI/CD is managed that easily. And I'll give you an example of it, how I have done CI without any kind of third-party application, just using Docker and made a production-ready application. So any doubts on what, not how, मैं दिखाऊंगा. Any doubts on what it's doing? Or maybe we'll come to that after demo. So so this is why I have made this Flask API. Basically, I'm not made. I actually most of it is copy paste. So this basically what it does is I have a Flask app here. This package, right? It's my Flask app. So this is not even Flask app. It's just a package that I want to run. This is the main file, and the rest is just package. In the main file, मैंने बस इतना कोड डाला है, and उसके आगे मैंने अपना पैकेज डाल दिया कि वो main file करना, उस पैकेज करना क्या चाहिए उस पैकेज को, ठीक है. And उसमें I have put tests as well. I've got tests here, and I've got build, I've got tests, I've got everything in this one package, and I just want to run it on with a proper production ready Flask. So ideally you have to set up Nginx, you have to set up a lot of complicated software to set it up production ready, a Flask app, if anyone has ever deployed it in a proper server. So that is simplified. So in this I have taken this base image, ये मेरी base, let's say it's a base class for references, उसको मैंने from लिया कि it's a base image है, उसमें मैंने अपना code copy paste किया, app code copy paste किया, then उसके अंदर I ran pip install requirements to download my dependencies, and then I ran my tests, PyTest करके I ran all my tests. So when this image builds, it will set up all the dependencies, and it will download all, it will test all the entire application while it's building the image. So I think don't focus too much on the code that I'm writing or whatever I'm writing. Just focus on what I'm trying to achieve. So यहाँ पे, as you can see, there are steps. All right. So These are steps. So first step is, as I've written in the code, is that I have taken the base image. I downloaded the base image पहले से ही. उसमें मैंने अपना code copy किया. Then I went to installing my dependencies and right now look, it's installing all the dependencies that I require. And then last में it's run the tests. So test run हो गए, एक test मिला, वो run हो गया, वो एक test pass हो गया. मेरा पूरा CI ready है and I have an application ready. And all I need to do now is, right now this Docker image is on my computer. I can copy this Docker image onto my server and then I can just do and just like that my application is a proper class application which is production ready, that you can run it on any kind of computer and it's ready to handle as many requests possible. It's scalable as well and it works completely fine and it has got testing, building sub ho gaya uska with just one command. That is what Docker offers. Now imagine this with React कि तुमने React पे सब कुछ, so you don't have to go, like I don't even need to go to the server and download Node.js और मेरा React वहाँ चल जाएगा. So this is what Docker offers. Any doubt regarding this small demo I gave?
Yes sir. अभी आपने जो डॉकर इमेज बनाई है इसको जस्ट हमें सर्वर पे डालना है और हमारा सारा CI/CD काम हो गया.
CI/CD तो when you made the image, right? CI/CD तभी हो गया तेरा image बनाते वक्त.
अच्छा.
Just because CI/CD पास हुआ वो इमेज बना, वरना इमेज नहीं बनता, वो इमेज भी फेल हो जाता.
हाँ, और अब बस हमें इमेज को सर्वर पे डालना है और रन करना है डॉकर कंटेनर पे. बस
हो गया.
ठीक है.
No GitHub, no pipeline, no third party apps. एक काम में सब हो गया. But then obviously you need to learn Docker, you need to understand how Docker works, and for understanding Docker you need a lot of operating system knowledge as well. So it's not the easiest thing to learn, but once you learn it you will always use it because it's just too damn good. Also in this application while I'm at it, because sometimes क्या होता है Docker को build करने के लिए download resources. So when you download stuff, right, it can take time. When you download resources, it can take time, and Docker images are very big. Like Docker images.
Sorry, again, it's not audible.
So you're not audible if you can hear us.
You are muted, I guess.
Am I audible now?
Yes.
All right. Can you all see the screen? Screen चलेगी.
So दिख रही है.
Okay, दिख रही है ना? Okay, yeah. So Docker images are not easy to build because right now it has to download the base image, उसके layers. So it can take time to build image, and obviously you can't wait if obviously it stores in a cache, so it only downloads what's necessary. But the first time waiting for it to download 968 MB is a waste. It's not very low. So this is where CIs again come into picture. So if you do not have a net connection, you can use GitHub to build your Docker images like I have done. So this is basically a Docker image ka wo CI. All it does is it builds my Docker image, and if I want, I can add another command here to store my Docker image in a registry. Like how code is stored in repos, Docker images are stored in registries. So I can put another command here to push the Docker image to a registry, which I have not because I don't have a registry as of now. But with this, I can build my code on GitHub. So like here in GitHub, you can see यहाँ पे मैंने patch भी डाला हुआ है कि image build हो रही है, that I have a new image ready. So in GitHub Actions, I have got this image CI, Docker image का CI I have coded. So as you can see, दो बार image नहीं बनी. There was an error in it. It did not happen. And all this CI does is what I tell it to do. Again, it's another CI, same as code build. जो AWS और दिखाया था पहले, it's similar to that. But this CI, it builds a Docker image. Because CI can do whatever I wanted to do. So this one build a Docker image, and because it's building on someone else's server, it uses their net speed. So if on my server the Docker image will take like a few minutes to build, on GitHub Actions that Docker image will be built. Even if it's 3 GB, 4 GB, it will be built instantly. Instant build हो जाएगा. So that is another reason why CIs work very well with Docker images, and Docker images are very easy to deploy, which I'll be focusing on now. So we have deploying now. Imagine if I have 4 servers, उसमें मैंने Docker image डाल दिया है. Now because Docker is so powerful, I can easily always put a best setup कि इसमें ये container यहाँ चलाऊंगा, ये container यहाँ चलाऊंगा. These containers share resources, so I can arrange my containers very well to get a very optimized system. But right now there's technology like Kubernetes, which all of you must have heard, especially those who are doing the 30-day Google Cloud course. Kubernetes. So what Kubernetes does is it is an automatic setup. उसमें Kubernetes को all you do is you give them computers कि ये तेरे server है Kubernetes 4-5 computer दे दिए उसको, and you say ये तेरे containers है कि these are the Docker images you have to run. Kubernetes automatically arranges the Docker images according to performance, ki what will require how much performance, how much request, and will keep adjusting them. If one of them requires more performance, it will replicate them, and it manages them over a fixed set of services. So generally when you scale applications, your cost increases, but when you use Kubernetes, your cost does not increase, and your application is scalable with zero downtime. And so when you add Docker and Kubernetes together, you get the most powerful CI/CD plus deployment time plus architecture possible. But kept in mind, this works only for microservice architecture, not for a monolithic architecture. Any doubts on this? I'm audible, right?
Yes, sir. Yes, you are audible.
Okay, so
Yes.
no doubts in this. Anyway, this is too advanced. I'm just telling you कि ऐसी technology exists करती है. I'm not going into detail of कैसे काम करती है. Obviously, we can do that in some later workshops. Basically, I'm telling you कि how this one Docker has completely revolutionized CI/CD and why it's so important. So, if that is all about Docker, then we'll move to the next topic. Next up, we've come to IAC. So obviously, like I said, I must you must understood by now कि जब तुम cloud कुछ करते हो, you have to rent machines, you have to rent servers. I think by this time everyone must have understood that fact. So this is easier doing that. Generally, what we do is I go here to my instances. यहाँ पे I go here, I start a new computer, rent it, configure it, blah 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 blah. उसपे सब software डालता हूँ. It's a very long process, and that just for one computer. Imagine if you can control what you want from cloud by code. I just type on my code file, this is what I need in cloud, and whenever I update that code file, my cloud architecture evolve. Like in my code file, I can, like, let's just say I have made a configuration file. So this is controlling my infrastructure, cloud infrastructure. So initially, my configuration file looked like this, and I had 3 servers connected to one domain name, like wexample.com will take you to these servers, which connected to one database. I want to change this infrastructure. So instead of going and manually changing all of this, I can just change it in my configuration file, and automatically my entire infrastructure has changed without any kind of overhead. जो change करना था वही change हुआ है, जो पहले था and it should not be changed has not been touched. So IAC helps control your hardware with code, your cloud hardware with code, and IAC is a very, very complicated thing because you need to know cloud very well. Like for someone to be like an IAC pro, you need to be a cloud pro before that, because IAC is only used by people who are like supremely good at cloud or at a particular section in cloud. I know how to use IAC for serverless functions, but then as I'm not touched serverless function, I won't be explaining, but I'll just show you what an IAC file looks like. So yes, so this is an IAC file. So this IAC file, okay, if you go to understand what this file does now, it basically it gives me a serverless function, और उस serverless function को node पे चलाता है, उसको ये code देता है, and उसको ये path देता है कि इस path पे you can request it, you can connect to it. That is all it does. Now let's say tomorrow I want to change, I want to make it a more in-depth architecture. I will just update this code with this code. Now this code is a huge, it's actually one of the most biggest, single function IACs I've seen. So this, if I replace with this, will just update my architecture to a more complicated architecture. So you go tools, like you submit them, जो तुम्हारी configure file है, you submit them to IACs and then they run it. Like for AWS, it's CloudFormation. I'm not going in much detail into this because I just want you to know कि ऐसी एक चीज होती है. Like later on when you become good at cloud, actually second year, if you're starting DevOps now by fourth, तो भगवान हो cloud. Okay, that time you can all touch IAC, and by that time IAC will be very powerful. And so I'm just telling you that IAC exists and there are tools for it on every cloud platform. AWS CloudFormation, Azure as Azure DevOps. And in the document that I'll be giving you at the end of the workshop, I have mentioned all of this that you would require. Still, any doubts on IAC?
No, sir.
Okay, anyway, it's a bit advanced. I'd agree if you don't get it. This is the last, I think, second last of all our topics. We're almost at the end of it. Thank you for bearing me for this long. I know it's been not the most interesting workshop. I've tried to make it so. But regardless, this is the most easiest part. Basically, this is कि अब मेरे पास machines है, मेरे पास software है. I need to manage them. I need to make sure they're always running. So this is where logging and monitoring comes into picture. On a personal level, as a student developer, you will never need monitoring as such because it's a problem नहीं होता. But having logging and monitoring on an industrial scale helps you find bugs or problems in your on your applications faster. So that is all about it. Logging. I don't know how many of you use logging. I think console.log or is logging. If you print, let's say you're writing a code now and you're printing them stage by stage. इस stage पे ये, इस stage पे ये हुआ. So that in a way is logging. Obviously, there are softwares that collect logs, even everything. Every computer program has a log. That is commercially everything has a log because your log is the best place to find bugs. So logging is very powerful in that basis. So there are a lot of tools for logging are there. I have mentioned those tools there in the Word document presented the tools that you can use for logging. Monitoring is basically when you have any kind of application running, you can monitor it. कितने requests are at what time. So logging and monitoring is basically for getting data of how programs work. So all of you, those especially those in ML and more, please look into logging monitoring because this gives you an entire dimension. Because this gets you into the AI in code, AI in DevOps. AI in DevOps is actually one of the most advanced DevOps fields there is. There are companies like Red Sky Ops which use AI to control your DevOps. So you're literally doing nothing there. So these things do exist and they need to be working on it. I don't have logging a demo, but I do have a monitoring a demo. So this, remember the server I showed you? This is a connection to that server. So as you can see, recently we connected to we accessed the server. So यहाँ पे there's a blimp. If someone accessed it, time भी देख लो. It was exact time around we did it. And this is this CPU utilization. It's कितना CPU utilized हुआ when we connect to the server. So this is like a server monitoring dashboard that I've set up. So I can always notice कि अगर मेरा server hack हो रहा है या overload हो रहा है, I can always have an eye on it with this. I can put alerts कि अगर इस line, if it crosses this point, मुझे email आना चाहिए कि your server is getting overloaded. So monitoring comes, and this is all running on a local machine and it's totally free. That's a fact. These kind of apps are totally free to use and they help you in so many ways. I have run this using Docker. It's a Grafana image for Docker. So again, Docker coming into play again. So just emphasizing on that. So this is where monitoring works. Any doubt in monitoring and logging? All right. I think, okay. Thank you. So that's no one. Okay, this is the last section. This section has no demos. It has nothing. It is not a bit. To those of you who ने आज तक क्लाउड सुना नहीं है, ये सुन लूंगा तो फिर अभी वैसे ही सर के ऊपर से जा रहा है. This is like the final, kill ending move. I am not saying the only reason I add this section is because a lot of you are starting cloud, and there are some things that you should know when you start cloud. because Varna cloud is not free. It is not something a developer to use for free. Credits मिलते हैं हाँ. Credits खत्म होने के बाद जो महंगाई बढ़ती है ना, because I myself when I started cloud have got bills of up to $64, and I had a very tough time explaining my parents ki what was happening that I had to spend $64, and I did nothing to do. कुछ किया भी नहीं हुआ, ऐसे मेरे कट गए पैसे because I was not careful with cloud. So those of you who have not started cloud, maybe just keep them in mind. Obviously, I've mentioned all of these in my mentioned these things in my the document I'm giving you. But those who have started using cloud, who use cloud generally, please keep these things in mind. First of all, is to understand that cloud is nothing. It is just laptops running in on a clustered location with very good Wi-Fi. That is it. Your server on a cloud is nothing but a machine that you can access, you can control, and it has got insane net speed. Like net speed is insane. So those things are in the internet. On your cloud servers, because when you get those machines, those are empty laptops. So you can configure them. How much RAM do you want in them? How much memory you want in them? What is the input-output speed of disks? And a lot of hardware terms coming into picture here. You can decide, do you want a Windows operating system? Do you want an Ubuntu operating system? And you can configure these things. And why configure? You could download kar raha nahi. Meaning when you rent the server, right? You can set up, I want a Ubuntu server with this much RAM, this much WO, and accordingly they will tell you the price. So always keep in mind of the price. If the price, some servers are free, some are way too expensive. Obviously, again, there's someone asked how do these servers connect to each other. All the servers that I own, let's say in that server farm there are like around 1 million servers. Usme se, let's say Alan John rented 3 of them. So those 3 servers are connected to each other in a virtual network, in a virtual private network. It's like a subnet. So talk between them, there are terms like DNS, API, gateways, load balancers, which I'm not explaining because बहुत advanced stuff है, but you all should keep this in mind. What exactly are you doing when you say मैं cloud से server ले रहा हूँ, क्या हो रहा है? जब तुम cloud server ले रहे हो, you're just renting a machine, a laptop, connect to good internet. You're configuring what your laptop का specs चाहिए, what is the and you're connecting all the laptops that you own to each other. That is what you do when you take a server on cloud. So obviously there are some, when you go to cloud, there is not only server renting. When you go open it, it's got like what? When you open this, there are all these features, satellite, quantum computing, all of it, and a plethora of features that you can explore in cloud. But all of them are nothing but specialized server. कि अभी जो तूने normal server लिया है, normal laptop लिया है, वो तूने खुद configure किया है कि मुझे इसमें ये चाहिए. Cloud servers like AWS, Amazon, Azure, Google, they give you servers with things set up. These kind of computers are set up for using Kubernetes together. These are pre-set up for these kind of servers are set up for you setting up database servers. So these are specialized servers that cloud gives you services. So they are nothing. In the end, everything is only a machine in a large server farm rented by you. That is what you should remember. Now, storage is a little different. Like someone asked about static hosting, storage is basically that. So in this, instead of renting a server, you're renting storage, because like I said, there are empty servers with a lot of net speed. Storage is also there in server farms, and there's a unlimited storage. So everything, Google Drive, Dropbox, everything, your GitHub, सब कुछ एक ही जगह stored है. It's just owned by different people. Like there's an amount of storage owned by GitHub. उसमें से GitHub थोड़ा तुम्हें देता है, जिसमें तुम अपना कोड डालते हो. So in the end, everything is just a huge storage space, and everything has an address. So when you go on cloud and store files, you're not storing files in a server owned by you or anything else. You're storing files in a global storage. So you're like a huge, big ass hard disk, where everyone is putting their files, but the provider decides who accesses what files. And serverless computing is basically, instead of storing files and storing objects and images and movies, you're storing functions and code and running them on that storage. So again, serverless computing is a very advanced concept and not many people use it. But obviously, if I'm telling you about all these things, might as well introduce you to that as well. If you want, later on we can focus on these things as well. Last but not the least, and the most important fact is, when you're using cloud, when you start any kind of cloud things, first of all, understand how security works. a lot of you who use Firebase or Google Maps never remove your API keys from your GitHub repos. Like Abhi, if you want to search on GitHub, I can find someone's keys and use them. So obviously, when you're talking about API keys, it's not a risky business because API keys में क्या ही करेगा, वो request भेजेगा, price बढ़ाएगा. But if you lose your cloud की access keys by mistake, and वो भी admin वाले account की access keys ना, that guy can do anything on account. He can set up like around what 128 GB 3 TB RAM वाले machines with i7 with a 16 GB पूरा लंबा setup करेगा and mine Bitcoin and take the profits. But this server का rent का bill will come to you because it is your access key. So access key, permissions and security is very important. And if you are doing any kind of cloud course and the person is not teaching you about security on the cloud, ask for your money back, because I assure you this is the most important fact about cloud security. How to make sure what is yours is not used by someone else. Regarding storing API keys and access keys in code, I know that you need to give the code, you have to access this, you have to API key ye hai. You don't need to put it directly in the code. GitHub has secret managers, there's Git secret, there's GitHub secrets, there are a lot of stuff that you can use to keep your API keys and access keys safe with you. So anyone using GitHub, anyone using anything like that, having access keys, please be careful with it, because बहुत महंगा पड़ सकता है. Like I cannot emphasize on this enough. You might be thinking it can go up to $1,000, $2,000 वैसे जाएगा, and that in a day. It can ruin you. It is that bad. If you ever make a cloud account, never गलती से एक private repo भी हो, access key मत डालना. Like I should make a full poster and put it on everyone's house. So okay, so that is all about cloud essentials that you need to know when you start cloud. Any questions?
Sir, can you show us the practical application of this? It's how to manage that keys and that one.
Keys I will show when I have a section. Right now this is to inform you कि ऐसी चीज होती है. I would recommend, because all of you use GitHub, I would recommend looking into GitHub secrets, like GitHub secrets. So just have a look into it. There are a lot of good practices and secrets. So here GitHub explains how you can store secrets. Like a proper example, you go to your repo settings and you add a secret, and how you use them in your code. So I would recommend everyone who uses GitHub to just go through them, because this might seem sort of extra calm and all these things, but it will save you a lot of time and a lot of hope. Later on, if we have another workshop focusing on cloud, I will definitely 100% cover this, because to me there is nothing more important than managing your access keys, because I have had bad experiences. I'm telling you uske karan. Good enough?
Sir?
Thank you, sir.
Oh yeah.
Sir, is there any course you recommend for starting cloud?
Yes. Right now I'm going to give you this document. I have made an entire document where I have showed where I have learned all these things. So Abhi, you can read it in that, but I'm going to tell you, I started my cloud in AWS. I did a course on Udemy by Stephen Marek. Stephen Marek also has a YouTube channel, which you can have a look at. He's actually quite popular in the cloud instruction field. Like he's got a lot of courses, a lot of stuff that you can check out. He's got a YouTube channel. I mean, he's got a page. AWS dedicated a page to him. Stephen Marek, community hero. They call him a data hero. So he's a. If you're looking at AWS, I would recommend his courses. He's really good when it comes to teaching cloud. Regarding even other things that I've mentioned in this entire workshop, I have put all the resources. Like in the end, I'll tell you, no matter how many courses you do, no matter what you do, in DevOps, the best source is always documentation. I learned you can learn theory anywhere, but the practicality of it has to be learned from documentations. So that's why, so get into a habit of documentations, because I have learned Docker from Docker documentation, I learned Kubernetes from documentation, and obviously theory, I have recommended channel sources that you can read from. So once I'll be sharing the document now after this presentation, once the questions are done. So don't worry, there are sources there, but yes, you can start with any course. The idea is to get a picture of cloud. In the end, how you grow cloud based on how, in the end, No one will use everything that's on cloud to database to use. It won't happen like that. Nah. You only use what you need to use. So courses can give you a good picture, but the best place to learn cloud is to run it yourself while reading documentation and of course pricing blogs. Galti say, I don't want to test a $10 per hour machine. I just want to test a free machine. So documentation practice are best teachers, but to start off, I would recommend courses like ones by Stephen Marek. If I ever find a post like that for GCP and other things, I'll definitely recommend, but I've never done courses on them. Because okay, another thing is if you learn GCP or AWS, anything else, right? You've learned all of it. Cloud is the same. It's just the brand that's different. Maybe tools में थोड़ा बहुत difference होगा, but like I said, everything works on the same principles. अब मैं GitHub Action use करूँ, Docker use करूँ या code build use करूँ, CI होता है. Continuity जैसे वहाँ हो रहा था वो वहाँ भी उसी principle वहाँ काम करेगा. So similarly in DevOps, everything as long as you get the gist of it, you can use any tool.
Okay, sir.
Anyone else? Any questions? Any doubts?
So sir, at times whenever we make a web app or some software, in presentations we also need to put up the costing, like how much would this cost. So is there some way to find that?
Yes. Very good question, but this is a more question related to cloud. Like when I touch cloud as a cloud specific workshop, I'll go more detail into this. But पूछ ही लिया है तो like every cloud application has what you call calculators. So you can have GCP calculators. So these calculators tell you can add कि मैंने क्या क्या rent किया है, and these calculators can tell you कि तेरा pricing कितना आएगा. And depending on documentation, you can keep changing the values. कि अगर मैंने इसी जगह ये हटाया मेन्यू से और ये डाल दिया, it is like normal like Flipkart तो shopping करते दिखाता ना इतना पैसा लगेगा, something like that. So every cloud provider has a calculator made. So those experienced in cloud already, those calculators will be very useful to you.
Okay, sir.
Okay, any other questions? So thank you for bearing with me, Vishal. We got disconnected. I feel really bad about that. And I know बीच में आवाज कट रही होगी. It's the faults of having an online workshop. I would have actually preferred, like even last year when Arpit was we did discuss कि बीच में I come third year came and gave a second year's maybe lecture on this once during the OSS classes. But then COVID happened, a lot of things happened. And even now, I would have preferred having this session as a non-online session, but things are not, it's not possible right now. I really hope, I know, especially for second years and all, sir के ऊपर से गया होगा काफी चीजें. It was a lot of information to take in, but my purpose was never to give you in detail information how things work. Like I said, it's not a how-to workshop, but a what is their workshop. You might not have learned कि Docker क्या है, Docker क्यों है, but then कि there's something like Docker and it's good. It's worth learning. You learn that these are practices that are worth learning. Like अभी तक CICD सुना नहीं होगा, but now you know about it, so now you can go and start learning them. So like I said, this is the end of workshop, but this start for all of you guys. I will give you where I learned stuff, what all you should Google, what terms you should Google and check. In the end, seek कोई भी सकता है. It is knowing what to look for, and that was the purpose of this workshop. After we will be putting up a poll on the DSC poll, and on this poll we will be deciding the theme or the topic of the next DevOps Cloud workshop. It could be on Docker, it could be on CICD, it could be on IAC. I hope not. I sort of बाप लोगों का काम है. And it could be on cloud. It's all based on you. So anything else anyone wants to add? I'll just share you the file as well. And once I stop screen sharing, I'll just send you the file. So don't leave when I stop screen sharing. Take the file and go. Anything anyone wants to add? Wants me to ask कि इसके आगे क्या? What next?
Sir, AWS is free or for students?
No cloud is free, but they have free tiers that you can use. Like right now the server I use free tier. Like obviously the most cheapest, like every kind of, like the सबसे सस्ती machine है ना, like the machine I showed you, right? Basically this. Do you know what the specs of the server are? जिस पर मैं ये चला रहा हूँ. It is 1 GB RAM, 2 GB ROM with a very slow processor. But then that is what is required. So that kind of server is free. So there's a free tier and they give you credits as well. AWS has, there are obviously a lot of platforms which give credits. So these credits that can be used to learn stuff. Not only AWS, DigitalOcean, Azure, GCP. There is a free tier for students to learn them and start learning them. So don't worry about that.
Okay, sir.
Just be sure to stick to the free tier. Yeah. Anything else anyone had to ask? Or should I start, end the screen share and send the file?
So guys, if you have any further questions, we have shared the Slack link in the chat. You can join that. And if you ever come up with some questions, you can post there in the DevOps channel and we'll be there to answer you.
Okay, then now that that has been confirmed, thank you so much for giving your time. It's a Sunday afternoon. I'm pretty sure all of you had a lot of things to do. I really know, I know okay, this is a very, over the top kind of workshop, but I did not know how to start with this because this is a series of workshop and this is the only way we could have started this entire, series. Over time, we will help you build up your skills depending on what you want us to build up on. And again, thank you so much for giving your time. I'll just stop screen sharing and I'll just send you the file. So just check your Teams file sharing.
I'm not able to see the chat. I think it's not enabled.
No, it won't be on the chat. I don't know chat. I can share a file otherwise also.
Okay, sir.
We'll also share it in the Slack link, Slack chat.
Actually. Share it there well. But अभी might as well पहले यहाँ share कर लेता हूँ. All right, I can't share it here. So probably in Slack, or I'll just share it with. I'll share it to a couple of students. Like a lot of people in this meeting, I know. I'll share it to them. You can share it to your friends and just go like that. Or obviously Slack पे डाल देंगे हम, because I can't share this file here, not supported. So all right, everyone. If you have nothing to say, you are all welcome to leave. Thank you again.
Yes, thank you everyone for joining.
Thank you,
Alan sir.
Thanks, Alan. Bye-bye.
Thank you, sir.
Okay, sir.
चलो अब नेक्स्ट क्लास में मिलते हैं.
Yes sir.
Hello, sir.
Sir left, I guess.
Okay.
Did sir left?
Yeah,
You can post the question in the Slack actually if you have something serious.
Okay, sir. I'll post it there.
Yeah.